So, hello everyone, and we are starting our sixth class of this data analysis series. And in this class, we are going to discuss histogram plots on different data sets. Histogram plot is used to analyze distribution of a numerical data set or numerical data, distribution of numerical data. Okay, and histogram is kind of a bar graph. So first we will create a histogram, then you will understand. So a histogram is a visual representation of distribution of quantitative data. I have written numerical data here. Okay. So it also it is also known as a frequency distribution of data points across a continuous range of numerical values. So enough of technical things. First we'll create a graph and then we'll do some reverse discussion. So the data that we have connected today is Titanic dataset. It's a CSV file that I will provide the link in the description. And it's a very famous dataset of data analysis and machine learning. So you can also simply Google Titanic GitHub, Titanic CSV, and you can get the data. This data has these variables. First is the passenger ID, which is nothing but a unique ID that is given to each row in the data or each passenger in the data. Survived. We all know that Titanic sank and met an accident, and some people were able to survive and some of them died. So this data set is a very good example for exploratory analysis also. On my channel, I have posted a video of exploratory data analysis using Tableau of Titanic dataset. So you can go through that as well. And some bit of exploratory analysis we'll do today as well. Then, so survived is the output variable for us here, right? Whenever we are doing data analysis or machine learning, so data sets are classified into two parts, okay? Or the machine learning is classified mainly into two parts: supervised and unsupervised. Supervised machine learning or supervised data sets are those data sets where we have input variables and output variable. Okay. So it is input or inputs and one output. We will discuss about this in later lectures, but here in this data set, every other variable other than survive is an input variable. So this is our
Hello.
tips.
Hello.
Yeah, yeah,
हाँ
yeah.
हाँ हाँ
So this is our
हाँ
tips
सर
data
टिप्स
set.
वगैरह करा
Yeah, we did this last time also. Last class we discussed this. So in this tips data set, you can see we are trying to predict what will be the you know optimum amount of tip, or what will be the amount of tip if the conditions are like this. So for example, if a person goes for a dinner, two-person on Sunday, person is non-smoker, female, and if the total bill is around $17, so how much tip should this person give to the waiter? Simple. So here the output variable is tip, okay, and these are input variables, okay. So as I said, we will discuss about this data also, but in this type of data set, again, this is an iris flower data set, okay. So iris flower dataset is a dataset about obviously a flower named iris. What scientists did was they collected 150 different samples of iris, and based on their sepal length, sepal width, petal length, and petal width, they labeled the species as Setosa, versicolor, and virginica. These are the three species. So here the output variable is this species. We will learn again more when we will discuss this new data set. So similarly, in today's data set, survived or what are the chances of survival is our output. Like, and this output will depend on various factors, and these are those factors, right? Obviously, passenger ID and name are not those variables, right? Passenger ID and name are not those variables which will help us in determining whether the person, you know, could survive or not. Okay, so these type of variables can be ignored, but other variables from like whether the person was traveling with a parent or child. Parch means parent or child this person was traveling with. So two parent or child, five parent or child, it's like that. SIBSP means sibling or spouse. So whether the person was traveling with sibling or spouse, so this person was traveling with four people. So whether the chances of survival were more if there were more people, like they could help each other, or whether the chances were slim, and if the person was traveling in a particular, you know, class. Class 1 has highest price tickets, class 2 has class 2 is second, and class 3 obviously is the lowest price tickets, has the lowest price ticket. So whether it was the case that person who were traveling with higher price tickets were, you know, kind of given a preference in taking them on lifeboats. Things like that can be calculated with this data. Okay. Gender, whether because it was said that females and childs will be, you know, saved first. So whether this was the case. So this is something that we are going to analyze with Tableau. We can open sheet, but our today's chapter is histogram. Okay, and we will use several graphs and visualizations to understand histogram. As I said, a histogram is used to analyze distribution of numerical data. Here we have many numerical variables like SIBSP, E-class, parse, fair, but the variable that we are going to consider today is age variable. Okay, so as you can see here, we have people of different ages. Okay, so there are some null also. Null will be automatically ignored, so we don't have to worry about that. But let's consider those ages which are valid ages. So this histogram will tell us several things. Okay. So first of all, what this histogram will tell us, if there is a numerical variable in a data, like here, numerical variable is total bill, tip, right? In iris dataset, sepal length or sepal width, all these are continuous numerical variables. Similarly, in the case of Titanic dataset also, age is a numerical variable, continuous numerical variable, right? So when there is a numerical variable, first of all, a histogram will create an x-axis, and on the x-axis a range will be created. Range. If we are calling it a range, that means it has a minimum and a maximum value. So what is the minimum age? Let's say 0 point something, 0.4. What is the maximum age in this data set? So in this data set, let's say 80. So this will first of all create a range. As we discussed, histogram is plot with, or our graph is mostly plot with two variables, right? Do you remember? Like we plotted bar graph, we plotted line graph. All of them had two variables. Line graph had uh, date and sales. Bar graph had segment and sales or region and sales. But in this case, only one variable is used. Okay, as the definition says, it is used to analyze distribution of a numerical data. Okay. So first of all, what is the minimum and maximum of age? This will be here. Then what it will do, it will divide this range into some intervals. What is the interval? Like let's say 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25 and so on. Okay. So first of all, it will take a numerical variable, mark its minimum and maximum, and then it will divide the minimum and maximum into several intervals. Okay, these intervals are what? These intervals are equidistant intervals. Equidistant means all these intervals have the same common difference. Like it will be 5, 10, 20, 15, and we can configure that also. Okay. Now, so our x-axis is ready, our y-axis is ready. So our variable is age, and we can see that in age we have this range. Okay, and when we have this range, so what will be the second variable to actually plot the bar graph? The second variable is count of passengers in that range. Count of passengers in that range, or in other words, the frequency of frequency of data in that range, or probability of data in that range, whatever you want to call. So suppose this is 0 to 5, right? This is 0 to 5. This is 5 to 10. Okay, this is 5 to 10. So in the range of 5 to 10 years of age, if we have 5 people, so this particular height represents 5 people. So what will represent 10 people? A height just double of this. So this represents 10 people. This represents 15 people, something like that. So now let's draw a graph, and then I will have a conversation with the students who are attending the class. So I will go to my sheet, and in order to create a histogram plot, if you go to show me and go to histogram, you can see what does it need. See, it just needs one measure. Is it saying one or more? It is not saying one or more. It is saying one measure. So we will drag age here. Okay. And now you can see only two graphs can be drawn with this selection of data, because we have only one variable. So either we can draw a simple bar graph or a histogram. So I'll select histogram. And when you will select histogram, you will see a graph like this. This is what I was trying to explain also. So here on x-axis, you can see range of age, like what is the minimum and maximum range of age. Okay. So minimum and maximum range of age is defined here. You can see 0, and here you can see 76 or 80. Okay. And it has divided into 0 to 5, 5 to 10, 10 to 15. So it has divided data into some bins. Some null values are also there. So you can filter the data, and you can filter out the null values. Although we will discuss about filters later in this class. But is this graph clear to you first of all? Here is count of age. So what are these bar graphs representing? These bar graphs are representing count of values or count of passengers in this interval of age. Like people who or passengers who have age between 0 to 5 in the data set, like everyone has some age, right? So there are 40 such people. So you can say 40 of them are children below the age of 5. 20 children have age between 5 to 10. You know, again, 19 children have age between 10 to 15, and then those who have age more than 50 are 96, and most number of people are within this interval 20 to 25. So this data set kind of tells us that there were more people of young age, that is like young age means 15 to 30, right? And people who were old, like very old, they are like one person in the age bracket of 70 to 75, one person in the age bracket of this. So now my question to all the students, is this data clear to you? So this is what histogram is. Okay. Now there are some other type of, you know, modifications, formatting that we can do. So now suppose we want to see these numbers on top of these bars first thing. So what we can do is we can drag the, this is count of values, right? So this is count of age. We can copy this. In order to copy this, I am pressing control. Okay. If I drag this, it will make the graph disappear. So I have to press control. I am using my Windows computer. So in Windows, we press control and then we can drag this to label. Okay. So by pressing control, we can drag variables. It will duplicate the variable and we can drag that. Like we can, or we will discuss about this later, but we can drag and put it on. Okay. So now on top of every bar, we can see that count also. So we don't have to drag our mouse over these bars to actually see that number. Now there is one more term. This is bin. Okay. So this variable, this particular variable was also not there in the original data. In original data, there is only age. Okay. But there is no bin. So what is bin in histogram? Bin is just like a group. Okay. So a histogram displays numerical data by grouping data into bins of equal width. Okay. And each bin is plotted as a bar. So this is each bin, you can see. Each bin is plotted as a bar whose height corresponds to how many data points are in that bin. Simple. So this is one bin, this is two bin, and there will be some n number of bins here. Okay. So 3, 3, 9, 3, 12, 15. There are 20 bins right now. Okay. Bins are also called as intervals, classes, or buckets or groups. Okay. So this is how you can remember bins. So now what we are going to do, we are going to duplicate this so that we can play more with this graph, understand it more. This bin variable, which was originally not here and it was created or generated by Tableau. So you can right click and edit. So you can right click and edit this variable. So when you will see, maybe the screen size is small. So what I'm going to do is I'm going to zoom it for you. Here you can see certain settings related to bin. So what is the field name? Suppose you don't want to call it age bin. You want to call it something else like age interval, age whatever you want to call. So you can change that. This is size of bin. Okay. Size of bin is 5.09, which is automatically decided by Tableau. So size of bin is what you are actually seeing, like 0 to 5, 5 to 10, 10 to that. So it is actually 0 to 5.09 or something like that. Okay. These are the ranges of value. So this bin has a minimum value of 0.42. 0.42 years. That means there were actually, you know, very young kids like toddlers also, infants, and difference is 79.58. Maximum value is 80. And what is CNTD? It is count distinct. Okay, we will discuss about this later also. So you can suggest bin size and it is suggesting this. Okay, and what we can do is, let's say we want size of bin to be 10. So we can say age is between 0 to 80 and we are suggesting a bin size of 10. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay. So actually there is one person. So it is counting that person who is 80 in the bin of 80 to 90. So it has created 11 bins. Okay. Now the data has more like the data has less number of bins because we have increased the bin size. We can again go to bin, edit it, change it to, let's say we want to change it to 2 bins, like we want only 2 bins. Sorry, we have made the age difference 2. So every bin has a age of 2. Okay. So the bigger number that we put here, let's say 50, 40, because 0 to 41, 40 to 82. So it will be like 2 bins, right? So that's how you can decide number of bins. 5 is actually an ideal number. So this is how it happens. So this is what you can do with bin, this variable bin. Okay. And later we will learn something called parameters in Tableau. Okay. So this is called parameters. So parameter is like a filter, is like a, you know, slicer or like a control. Yeah, best word will be control. So let's create a filter something. Now this filter is there, and I will tell about this filter later, and we will, show this filter here. So here you can, what you can do is, now you can dynamically change the bin size. Okay, this is dynamically changing. So you can see, and based on what, this is a control, right? Based on what value you are choosing, it is showing that data. So you will learn about parameters later. Parameters add more control over your data. It makes the graph more interactive, so that, you people can analyze it with their choice. Like suppose they want to change the variables and see what will be effect of those variables on the graph. So that's why they use parameters. So parameters will be taught later. I'm deleting this. And because we selected it to be a value, so now let's change it to a value. So we will learn about parameters later, but this is very important. Now we'll duplicate the graph. What else can we do with this? So we also have various dimensions. Okay. So one very important thing that we can do is, let's say we want to analyze how the age distribution is there in the data as per gender. So gender has two values, male and female. So if you have a dimension which has two or three values, two or three distinct values, so you can drag that to color. Okay. So now you have more details in your data. So I'm showing it once again. You can drag it to colors. What is this showing us? Look at the numbers here. So between the age of 25 and 30, there were 116 male and 65 female. Okay. In the age of 0 to 10, there was 26 male and 24 female. So you can see the ratio also, like in which ratio they were there. Between age of 65 and 70, there were no female. Okay, very good. Now let's duplicate this once more, and here we will drag survived. Okay, so we will drag survived here. Now when we are dragging survived here into color, it is not giving the same effect. It should have given the same effect, right? Because in survived also we either have 0 or 1, but it is not giving same effect. All it is doing, it is actually changing the color of blue. So lighter shade of blue is representing 0 and darker shade of blue is representing 71. You're not able to understand it clearly. So before adding survive to this sheet as a color, what we have to do is, let's remove this, because this survived here is listed as a measure here. Okay, yes, it should be a measure because it's actually a number, but when you have to analyze it in this fashion, when you have to analyze it with colors, what you have to do is you just create one copy of it, you just duplicate it, and you just change that copy to dimension. Okay, now we have two copies of survived. One is numerical survived and one is dimension survived. Okay, dimension will behave as a string. So in dimension, that 0 and 1 is actually yes and no, or true or false. Okay, so when you will drag, in case of that, when you will drag here, so when you will drag into colors, you will see this. Okay, so now you can see in every age group what is ratio of survived to not survived. So you can clearly see those people who are male, and because in this group you can see all of them were male, all of them died. Okay, unfortunately. Here you can see between age of 0 to 10, 34 passengers survived, in 16 could not survive. So this means that more attention was given on saving very young children. Okay, then here also 15, 18, but here the ratio is number of people who died was more. Okay, so this is one case, and here also you can see the distribution. If you want to change color, you can, you know click here and change the color palette. Like you want to include red and green or whatever, red, and for this you want to do this color, apply. So you can change the color accordingly. Later you can create dashboards, and you can actually drag these two sheets together to understand data with more details. You can increase the size. Let's increase the width to 720 pixel or more, so that we can compare them side by side. Okay, Now what we are going to do is, again we are going to copy this, because we are going to analyze the distribution of data with all dimensions. Okay, this is how we kind of explore data. So here we have one more dimension which is very important, and that is passenger class. Passenger class, as the name suggests, is actually a name and not a number. So we will not create any copy of it. We will directly change it to dimension and then drag into color. So you can see this also, right? So this way you can see distribution of passenger class in various ages. So by creating graphs like this, you will get some data like how the variables are distributed and how you can analyze things. Now suppose we have passenger class and we still want to analyze survived versus not survived. Now you can drag survived into columns. Okay, so it will create two columns for us, one with 0, could not survive, one with 1. Okay, now we can analyze data with more detail. So here blue color represents first class. Okay, and you can clearly see 1 means survived. Okay, you can see people who were in first class, there are more blue people here. Okay, than there are here. So it gives an indication that people who were traveling in first class survived more, were able to survive, right? People who are traveling in third class, more people are here, not survive. People, okay, here the ratio is almost equal. Okay, so this is what you can see from the data. Like people who were from first class were kind of given a preference. Okay, similarly, the similar thing you can do with gender also. So here it is gender. Now just create another column. Okay, so just create another column and now let's analyze this. So blue is female. In which section do you see more female here? This is a question to students. In 0 section or 1 section? So you can, if you select female, you will see that. Obviously, now you can clearly see the numbers are higher than what numbers are there, right?
Mm-hmm.
So actually the preference was given to female, children, and people traveling in first class. Okay. You can analyze them all together also. I will explain that later. But this is how you can explore the data, like which variables have an impact on survival, which variables do not have, right? So this is how you can analyze this. And now with the help of this information, I will kind of ask you to do some exploratory analysis on your own and prepare some dashboards also, right? Prepare some dashboards and show us some kind of analysis. Like your dashboard should also represent something meaningful, right? And whatever you will show, we will then evaluate that and we will discuss and then we will proceed the class. Okay.